Okay, good morning, everyone. Thank you, Sarah, for the intro. I run Marketplace at VMware. Marketplace it's an enterprise marketplace for software validated by VMware to run on VMware data center software, whether it's running in the private cloud or in public cloud. It's a two-sided marketplace, so we have customers and publishers. The customers get validated software. They get immutable software, like once it gets onto the marketplace, it doesn't get taken down unless there are some security issues. Then we keep the versioning consistent across various versions. The software is easily available across VMware systems. So if you're running something, a vSphere in your data center, then you can just connect to the marketplace and download the software, validated software that is running on VMware. And we provide some semblance of supply chain security, so we will give some metadata related to the tests that were run, the licensing models, the open source licenses, and the other capabilities that are there in the software. For publishers, the capability we provide is being able to upload software, so the customers don't have to go discover the software at the publisher sites or the ecosystem sites, and then being able to submit it, and automation, a bunch of automation built in to validate that software on various VMware substrates. I mean, VMware has obviously the vSphere, which is like virtual machines, but we also have Kubernetes and a bunch of other technologies on which we need to validate this software to make sure it'll run in your data center. So this is a two-sided marketplace. It basically is built. It's a modern app. It's built using microservices, runs on Kubernetes. We use service mesh, and we use a bunch of other tools, which the recent talk talked about, panel talked about various tools that are available. We have used a bunch of them. Obviously, being part of a large organization, I mean, there's a lot more governance around security, around data governance, around data, around cost, and so we do have a golden path that we use, and that is kind of integrated in the marketplace service. I apologize about the quality of the image. We were trying to do a model into a blown-up image, so a little bit not very high fidelity, but basically you can, this shows a workflow for the consumer that they can connect directly to their data sources, their compute sources, and network sources, and deploy the software directly from Marketplace. So I'm going to talk about the incident that happened last year around November. It was a very interesting incident. The setup was that we had to push a hotfix, and this hotfix kind of came about because one of the third-party libraries that we are using did not follow semantic versioning. So they updated breaking changes, non-backward compatible changes in a patch release, and our automation and regression systems were not doing testing, full-scale testing for the patch releases, assuming that semantic versioning was followed. So the site came down. We had to do a quick hotfix for that. Once we did the hotfix, it was around noon PST. So our services were already running. We just pushed the hotfix. But next day, as our services, we generally run 3 pods for one of the catalog services. And the pods, as they started horizontal auto-scaling at the start of the day, one of the pods started seeing an exception. Right? So, and that was because a wrong config file was pushed as part of a part of the hotfix. And what happened was we got a developer exception through Sentry within seconds. But because 3 of the working pods were still working, and sorry, that's a dual use, but 3 of the working pods were still handling most of the traffic. So our tools, incident management tools, which were testing the pods, we use Uptime, they were still running against it, and they were still hitting the healthy pods, and they were not getting any exception. And the first incident management event we got was 15 minutes later when we got paged, and the command center, the SRE teams, everyone got in here. We got a bunch of alerts. Then we got a pager duty. The engineer on call got pager duty, and a bunch of incident management machinery kind of took over the whole event. Then we figured out, as more and more engineers get involved, the scope of the problem got bigger. We had to reset some of the working pods, and we realized the problem, and the problem took almost 2 to 3 hours to fix. We kind of ate away all our error budget in this just one event, and that was, a lot of it was quite avoidable. Like a lot of delays that happened in the whole incident management were quite unfortunate, and it caused a lot of issues for us later on. But eventually, everything was restored. The status page was updated, and the service was up, and the customers were able to use it again in their data centers and being able to deploy the software through the UI and everything else. So and this is the right WTF, but what happened in this case? So just looking at we did a bunch of postmortem around this and tried to figure out what happened. So what worked? First of all, we were very eager to understand what worked for us. The circuit breakers, our app is a collection of microservices, and for all third-party services, we have a bunch of circuit breakers. So the circuit breakers worked. Like the apps were not sitting in an async loop waiting for the I/O to complete and hanging there or crashing. It was just, it will return, it'll give an exception, and the code execution would move on. Other services continue to work for us. The whole incident management, in a 30,000 people company, defining an incident management system, having the runbooks, having the standard operating procedures for SaaS applications, being able to bring various teams together and getting them to follow a recipe, that worked pretty well in this case because everything was, once the incident management machinery kicked in, it worked quite well. The third thing that worked very well for us was the concept of micro front ends. Our app is a collection of front ends. We have a different header, the side navigation bar is different, the catalog is different, and the other aspects of the app are different front ends altogether connected to their specific backend. So while the catalog was not working, the rest of the app worked, still kept working. You could do your user management, you could look at your subscriptions, all other services and the front ends for them worked fine. So what didn't work was semantic versioning didn't work in this case. Like even for a dependency, semantic versioning was broken, so which caused breaking changes for us, which caused this incident in the first place. So we kind of lost, we have to figure out how to do dependency management. What are the things we need to do for dependency management, making sure that the dependencies that we are using are not introducing any breaking changes in the code base. So how we fixed it? Sorry, let me go back. Okay, the second thing that didn't work was config file change. Like we were not using versioning in the name of config file. Like config file was still in the code base, but it was very easy to, unless you looked at the timestamp when it was last checked in, it was not very obvious that there is a change in the config file. So that caused the oversight in this case, which caused this issue where our production system was pointing to a development database, which caused this issue in the first place. And the third thing was our uptime alert is too delayed, but in this case, there were 3 working pods, and uptime was hitting the working pods till it started hitting the failing pod, or it would intermittently hit the failing pod. Because there was not a lot of traffic coming on the first pod, the new pod that was spun up, as it warmed up and traffic started hitting, our observability, the P95 errors were not high. Like we were not hitting the P95 error alerts. So the metrics, the systems that were set up, they were just not getting triggered in this case. And the interesting aspect here is what can we do to reduce, or the interesting discussion we had is what can we do to reduce this gap between when we got the alert from a developer exception system, which is Sentry in this case, and the incident management system, which is using the third-party tools such as Uptime and observability tools and other tools that we have in our machinery. So the learnings we had, one was when updating the dependencies, we cannot trust the versioning. So we have changed our push to production for all dependency changes, which is pretty much every time. When you're pushing to production, we do weekly pushes to production. So every time we have dependency changes and we do run a full suite of tests. Now that's a trade-off, right? Because the whole end-to-end regression tests and everything takes a long time. So your production lead time is much longer. But that's the trade-off we took initially, that we will not do that, but then we were forced to do that because in this case, it was a pretty catastrophic incident. The second was versioning the config files. So our versioning, as I mentioned, was not time-stamped. It was more just putting in the GitHub or the GitLab in our case, and it was just very difficult to see. Like someone would know, oh, I need to look at the config files. And that was pretty evident once we looked at the logs and the failure that was happening, and the Elasticsearch instance was not returning. But once we figured that out, we had to go look for the config file. So it would have been much more obvious if the config file change was very evident from the name itself. And so we changed the format where we add the timestamp of the config file to the name itself, just to easily identify for developers when was the config file changed. Third, we do integrate Sentry with PagerDuty. That is the hard part, right? Like, how do you make sure that the developer exceptions are connected with the incident management and other systems that we have? Now, there is, this is more art. This is where art of engineering kind of comes in, because, Sentry generates a lot of exception alerts, a lot of false positives, and you don't want your incident management system to be getting all those alerts, right? Like, you don't want, your SRE team is going to hate you if you connect your Sentry to PagerDuty and they are going to get paged every time you push code to production, or every time there's a new change coming on, or even if there is just a normal exception, which is not catastrophic. So the discipline, the governance that you have to push there is to make sure that your alerts and exceptions are properly identified, they are properly installed in your code, you have the right exception handling. You do have different classes of alerts, and only for certain class of alerts, you generate these incident management tickets. For us, that tuning is still going on. Like, even after 9 months, we still haven't found the right balance of what it should be. The important part is this is a separate PagerDuty account, so it's not connected with the organization's incident management system. But it is an iterative process to understand how do we connect a development exception system to an incident management system to make sure that we developers or my team can look at these issues way sooner than the incident management systems get triggered. Now, we could have done some other things in this case, like we could have drained our pods if we saw some exceptions. We could have changed some of the more I would say exotic things on the Kubernetes cluster side to bring this problem to forefront much earlier. But I think in a normal environment, or at least in our case, we just don't have that kind of breadth of the Kubernetes operational experience that people need in order to do that kind of set up that operational fabric. So the best for us, the best approach was to connect developer exceptions with our incident management system, or in this case, just connect it with a developer PagerDuty and get paged. Initially, when we set it up, I'm on the PagerDuty always because I'm the third line of defense, and I would get paged like every day. Every day I would get paged for some exception or another, to the point where I started, I blocked that number, like from PagerDuty, because I was just getting texts all over the day, and at night, and all the time. So that is the challenge, right? Like figuring out which exceptions you want to pipe it through to your incident management system, or even get paged about, is a challenge in this case. So That's pretty much it. Love to hear from you guys what do you think and any questions you have. But it was a huge learning moment for us, and I hope it gave you guys an opportunity or a window of opportunity to learn about how some of our systems work. Thank you. No questions?
Yeah. We're going to wait, see if anyone has any questions. Perfect. There's a couple. And while we're getting mics, actionable. I think the combination of incident management with what devs, like the dev exceptions, make them solving that problem actionable. And so I think that like learning that you had and kind of that improvement in what worked well, I think was on point there. Dev workflow. It seems like it was easy for devs to push to prod, and that was the learning that you had. And so it was integrated into the dev workflow and easy therefore, but maybe a learning of like, what might devs actually do? And then where
that's
it kind of
the trade-off, right? Like as a leader, how do you make sure that the right checks and balances, like how many obstacles do you want to put in the path of production, going to production? Some are necessary. Some, you want to reduce as much friction as possible, but some of these changes are kind of necessary, right? So make sure.
And then the open, I think, you mentioned run books and kind of how that worked well, like you were able to actually resolve the problem. And I think that's a sign of openness though within the company, right? So
yeah, that is actually very important, right? When you're running multiple SaaS services, having a common set of run books, having a standard operating procedure which everyone follows, helps the service teams like ours to know, like not invest or not invent the whole process ourselves, right? Like what is the process we have is very, very pedantic in the sense they kind of talk about, hey, you need to have this page of duty policy, this is the escalation policy, this is the these are the people who will get paged all the way up to the CEO if the things are not getting responded to in a certain amount of time. So the status page update policy, all those are very well defined. So it helps us not worry about all those things in a large company because that grid or that operational model is provided to us.
Yeah, no, it makes sense. Question in the back.
Yeah. Do you find the knobs and dials available in the combination between Sentry and PagerDuty enough to help dial down alert noise, or would you like to see there more knobs and dials put into that kind of an ecosystem?
I would like to see more dials. Like one of the dials that I would like to see is if this then that kind of dial, like if this alert happens and that alert happens, only then do PagerDuty. Right now it's only one level, right? Like you just say, hey, these alerts, send them to PagerDuty. But more, one of the reasons why we use Uptime is we can provide the whole flow, like log into the app, then go to the catalog, then try to download it, then go to this data center and see if you can push there, right? Like in Sentry, but it is just very one level right now. I can't define any logic there. So I would love to see that because that will be really helpful for the developers in that case.
They should turn it on in a second. Someone. Test. Oh, here we go.
Hi. Good morning again. Thank you for the wonderful talk. So I have a question that's kind of two-pronged. One is really, I think, specific to you and your company, and one is maybe a broader question. You might have an answer. Folks in the community here might have an answer. So the semantic versioning is like kind of like a really fuzzy, stressful problem for me. It was, I worked at NPM and can definitely attest that like it is definitely a relative term, not everybody observes that equally. And I think, different companies kind of take different strategies, right? So at Stripe, it was like a 6-month policy for like we're not importing anything into this code base unless it's been out in the wild for 6 months, right? And so I'm curious, like, was there kind of a tolerance that was implemented or was missing?
So we do have that, we did have that tolerance for the major and minor releases, but generally because security updates come in the patch release, unless they are breaking, like they are non-backward compatible or they are breaking changes, that's the policy we were following. Like we would do that for major and minor releases, but we were not doing that for patch releases. It was pretty much automated. And that, I mean, that is the one that caused this incident in this case.
Yeah. So it was like, did you all just stop trusting patch releases as well?
Like
okay,
we
good.
just said, okay, all three
I was going to
versions.
advise you to start doing that, if not. But the other question is, I think, the broader question for me, which is kind of around, it would be really nice to have some common infrastructure, tooling, guidance, whatever, around, how to accurately make sure that you're properly following semantic versioning, for library authors. And I'm just curious, like, do you know of anything that exists in the community? Do others in this room? Because it's like we can fix this problem, we just need some tooling, so.
Yeah, I'm not aware of any tooling, but love to hear from others. That is a very consistent problem, actually, in using third-party libraries, that different people have different interpretation of semantic versioning, and that causes a lot of problems when you are combining systems to build an application. But would love to hear from anyone else.
Continue that conversation for sure. One last question?
Sure, yeah, I just want to say first about the runbooks as well. Like, it doesn't, in my opinion, matter how big your organization is. Like, even if it's just yourself maintaining something, it's very nice to have.
Yep.
The top of mind is literally check Sentry, because I forgot to do that several times, and it would have saved me so much time. So, yeah, I recommend it.
I mean, in this case also, we got Sentry alert 3 seconds after the incident happened, right? Like, if we checked Sentry, I wouldn't be standing here today, right? Like, so.
I did not pay him to say that.
No, it's just, but yeah, my question about the config is, maybe it's too specific, but did you add any, after this incident, did you add anything to your runbook about like checking that, or did you add any automation to ensure that the configuration wouldn't get out of sync or like prevent dev or other environments from like cross-polluting into your production? And just wondering.
So yes, we did. We took 3 corrective action in this case. One was obviously versioning our config files, which I talked about. The second was not testing what we talked about, the semantic versioning case. And in that case, we did update our runbooks to see not the incident management runbook, but our own internal runbooks that we have to look at, hey, when an exception or when an event happens, this is the process you follow, right? You look at your observability, you look at your logs, then you look at the services, you look at the pods, you go through a whole process and you figure out where the error is happening. The third one that we did was updating our runbooks more around how do you update, updating more around checking Sentry and other tooling that is coming. We have a bunch of other tooling that generates alerts. So consolidating all those alerts into a single panel, but that is kind of, it's only us, we follow that, and it's a hit and miss with the developers. Like, some of them want to use it, some of them don't use it, so it's difficult to implement. But the first 2, we pushed it into the code base, and we made sure that we are following those. Did that answer your question? Okay.
Well, thank you so much, Arun.
Yes, welcome.
I thought that it was very apt to have an actual example of something instead of just talking in the abstract. So I appreciate you sharing that.